Hello, my name is Tom Walski with Bentley Systems. I'm here today in my role with the Water Distribution System Analysis History Committee as part of EWRI. So what we're doing is we're recording interviews with important people in the water industry and talk about how water distribution system analysis has evolved over the years. So today is October 14th, 2015. And we're at the AWWA Water Infrastructure Conference in Bethesda, Maryland, and we're going to be talking with Dr. Sasa Tomic from HDR and hearing about his experiences in water distribution system analysis. So my first question, Sasha, is how did you get involved in this particular field anyway? Did you start off in school working this way? Because a lot of our people started off as structural engineers or math majors or something. So what is your background? How did you get into this business?
That's a great question, Tom. I actually started with a desire to become an artist, but what happened over time, I grew up in a communist country and we were required to select what we should do at the age of 14, which is pretty young. And my dad is a hydrogeologist specializing in water resources for karst areas, and he wanted me to follow in his steps. So he gave me a pretty simple choice. He said, if you want to have a sure business, you can either feed people, or you can bring them water, or you can bury people. And I'm a lousy chef, so the choice was relatively simple.
Okay. So you had your bachelor's degree over in Europe,
yes,
right? At what school?
I went to what's now Bosnia, to a university in Sarajevo in Bosnia, which then was former Yugoslavia.
Okay, and then you ended up in Alabama.
University of Alabama, yes.
So how does somebody think, did you go by the alphabet and Alabama was A or?
Actually, when I started applying for a school, that was before the war in Balkans started, and I applied to several different schools. I had a friend who was at the University of Alabama, and she was helping me with English because I didn't know much English then. And she applied me to the University of Alabama using her address as the return address. So I don't know if I was ever accepted in any other school because if they replied to my home address, and war by that time started. I wouldn't want to find out if I was accepted at MIT, but I ended up at the University of Alabama.
Okay, and if I remember, your specialty was more on the stormwater side. Weren't you working more in that than in drinking water, or what was your PhD on?
So my PhD was more in stochastic hydrology, dealing a lot with rainfall runoff and deterministic stochastic models. But as I was doing my PhD, I went back to my love of computers, and while during my master's I completed requirements for undergraduate computer science degree, and then as I was doing PhD I did masters in computer science. So what I was really specializing was computer modeling of water resource phenomena, and I did end up in the right place.
Okay, so but your strength then goes across drinking water to stormwater to wastewater and all of those areas.
Yes, I split my career about equally between academia, developing software, and consulting world, and it's equally I split it between stormwater, wastewater, and water distribution.
Okay, so then you went out and did what with your job career?
So after I finished college, I joined Hazen because that was one of the few places at that time where you can combine computers and water resources. I actually applied for a big entry-level position, and John Hazen wasn't sure if he wants to hire a PhD to do support. Darrow Kirkpatrick was the one who convinced him, and thanks to Darrow I ended up at Hazen. I moved through the ranks fairly quickly. After 3 months I was leading the support, and then switched to testing. I did have some experience in software testing because my undergraduate thesis was testing DoFlow software by Delft University. So I knew how to test software, and then moved into development and ended up leading the team that built GEMS platform.
Okay, so you got to see modeling evolve from being more of a draw your own maps to being GIS integrated then.
Yeah, I started at that interesting moment where we figured out the algorithms and we resolved the issue of the computer capacity. Computers now could do larger networks, but it was time when we needed to figure out how to get data in the models. Developing the interfaces have been developed, CyberNet was already out there, EPNet was developed, KYPipe was there, but I took off when we were finding the ways how to get large amounts of data into models, how to integrate GIS, how to integrate SCADA, etc.
Okay, so you evolved then into more of a development role, but then you went over to Wallingford Software, right?
Yes.
And what about your roles? You said similar roles there?
It was slightly different. So when I worked with Hazen, we got to develop GEMS platform, and that was, in my opinion, the best planning platform out there. Wallingford Software is more operational and assessment platform. It's a different type of software, and my role at Wallingford was the role of a product manager. I did not do any development there. I was more being the link between the sales and the client and the developers, because sometimes this link is not there, and making sure that what's developed is what client needs. That was my job.
Right. Yes, so a lot of the computer programmers are not necessarily water people, and you need somebody like you to translate between the two, right?
Exactly. Even where we have programmers who came with the water resources background, there are often not the people who use the models. And in the software world, there is saying you have to eat your own dog food. So you should be using the software to understand how is it used. And that was why I enjoyed the role. It's like conveying what the requirements meant to developers, and then making sure that the tools are implemented the way the clients would want to use them.
Okay. So do you do much as far as actual studies yourself, or are you just more holding the hands of the people using it?
I did get to use models a lot, but I get to use models even more now that I am with HDR. And I think that actually closed my career, at least closed the full circle on my career, because I worked on the algorithms in academia, I worked on developing software, but only when I got to use the software in a real-world environment, I understood what it really means and what is that we were developing.
Okay, so now you're in a role where you're applying it and actually working on cranking out studies. So your role now is you're sort of the senior modeler in the company? Is that the...
I'm a senior modeling lead. It's slightly different because I don't get to develop models as much as I'd like to. I'm more involved in setting off the projects on the right path and making sure the right tools are used for the right reason, and following the project along, doing the QC, making sure that we have the right stuff to do the right job, and also to help HDR sell our services.
And so, do you have any special studies that kind of stick out in your mind as being really interesting cases?
So what was most interesting for me, and maybe not what you're asking, Tom, is how we developed GEMS platform. Okay. Because John Hazen gave us opportunity to try and to fail, because what we originally set off to develop is a model that's fully integrated with GIS, and we did that. We developed the first draft. It was called Preview Edition, but by doing that we realized that there is somewhat of a burden on the modeling to be tightly linked with GIS, and then changed our mind and developed a completely different platform that allows you to work inside or outside of GIS. It was interesting because it was just two of us and working 24/7 for a year and a half.
Right. Yeah, I can remember, sending you guys an email like at 4 a.m. and getting an immediate response back.
It was fun time. I got to work with some of the smartest people in the industry, having support from you guys, from the main office, but also Scott DeVoe and Ben Wilson, who are the smartest guys.
Yeah. Okay.
I can probably do that better.
So that's okay. So the trends that you see coming up now, from taking from history out to the future, now where do you see the water distribution system analysis heading?
So we already talked that modeling change over time. In 80s, and you know this very well, it was mostly about getting computers to give you an answer. We didn't worry how to put the data in they were small networks. Algorithms have been finalized, but they needed some touch-ups. In 90s, it was more about interacting with the computer, developing graphical user interface. End of 90s, early 2000, we now had computers that can do everything we want. The interface was there, but we wanted to put a lot of data in the models. And then towards early millennium, we started linking to SCADA. We now do have models finally that are linked to everything. They can be linked to everything that they should be linked. And I think for the first time we are moving away from building the models and refining the tools into using the software. I think the future is going to be very exciting because we're going to move away from having these single study models and look into building sustainable models that will be used across the utility as decision support tools, as emergency response tools, as mitigation tools. It will help operators understand what's happening between the points where they know what's happening and what will happen in the future when they don't know what could happen.
Right. Okay, so do you interact much with the research community? You follow many journals, or are you just so busy just cranking out work that you don't have time for that sort of thing anymore?
So, of course, we do a lot of research through AWWA EMAC committee, and that's primarily the involvement and the level of research I do. I follow the journals, I understand what's going on in the industry, but being in consulting world, I don't have as many opportunities as I would like to do research.
Yeah, that's usually what's happened in our industry is the researchers go one way and the practicing engineers go the other, and communicating between them is one of my pet topics, is trying to, both sides can learn from one another, yes. So do you write many papers anymore, or are you more just going to conferences and learning this time?
Not on billable hours.
Yeah, right, that's the other thing too, is your time is accountable, you're not on a grant or anything of that sort.
Exactly.
Yeah.
I would like to, and HDR supports it somewhat, but the preference as a consultant is to be in front of clients. So I do a lot of presentations and workshops, but no research papers.
So any really interesting studies you're working on right now? Or do you not want to talk about client software at this time?
I mean, there are quite a few amazing studies. Just recently, we worked for a client who had some problems with water quality, and they wanted to use their model. And it was a simple steady state model, never calibrated for water quality. But what happened is they stopped injecting chlorine in the system, and they wanted to prove to the regulator is that this was an incident due to the pump failure that the regulator actually seen in the collected samples. And we were able to very easily extrapolate a steady state model with assumed patterns and run it for water quality to match observed conditions, because it was relatively simple pulse moving through the system, which encouraged me to maybe even trust models more than what I'm used to, because I typically tell our modelers, like, don't try to do water quality before the model is fully calibrated. But maybe models are better than what we give them the benefits of doubt to.
Yeah, it seems like more and more when the model and the field data disagree, the model is often right and the field data is questionable.
Absolutely.
It's just the opposite of what we were trained in school.
We discussed it yesterday in our model calibration workshop, is that what we struggle with model calibration is data cleanup. Model calibration is very easy. If we had a model with accurate data, calibrated C factors would be a breeze. What we struggle in a calibration is closed valves, wrong pump curves, wrong boundary conditions, basically wrong input data, not hard to calibrate model. It's wrong to calibrate model.
Okay. Do you get much involved with optimization or that sort of thing in the practice?
Not as much as I would like to. I think that's one of the avenues where the modeling is going. Particularly optimization in a sense of decision support tool. Optimization for calibration, I think models are well enough calibrated when the C factors are plus minus 10, where they don't necessarily need an optimization to get the C factor down to a decimal place. But using optimization to identify leakage, or to minimize pressures, to maximize leakage, to optimize capital investment plans, that is an area that is coming because of the computer power available. Today we can go to Amazon and rent 250 cores to do work, which wasn't as easy even a few years ago.
Okay. So where do you stand on Darcy Weisbach versus Hazen Williams?
I'm okay with Hazen Williams as long as it stays within what's intended to 6 to 16 inch diameter pipe water at about room temperature. And I'm actually okay if one of these is validated, but two, that's pushing too much. Like large sewer force mains, I would stay away. Low pressure, large pipes, I would stay away from it.
So thanks a lot for participating in the interview, and it's going to be part of our body of knowledge when we're constructing some kind of report about how the industry has evolved over the years into where we are today and where we're going in the future. So thank you, Sasha.
Thank you, Tom. Thanks for the opportunity, and I'm really looking forward to see the final product.